So let's have the solution to example 13. This is about the load combinations 2010 and 2015. A simply supported interior steel beam, area cross-sectional area 18,400 mm square, must carry the following loads aside from its own weight. So we have here uniform load, live load 4.5, earthquake 3.2 kilopascals, wind load 2.4, dead load 3.6, which is the weight of the slab. Roof live load 1.5 kilopascals. All loads are gravity loads. Specific weight of steel to be used 77.30 kilonewtons per cubic meter. If not given, so assume specific gravity 7.86 times 9.81 and you'll get close to that. These beams are spaced 2.5 meters apart on a simple span of 10 meters. Determine the critical factored moment in the beam in kilonewton meter. The critical factored moment is the maximum moment based on the load combinations given. So for 2010 NECP, we have to solve for dead load first. So we have dead load 3.6 kilopascals times the spacing, this is 2.5 plus, so this is now in kilonewton per meter plus the weight of the beam itself. Specific weight 77.3 times cross-sectional area in meters square. So that's why we have to divide 1000 square. W dead load is 10.42 kilonewton meter. By the way, the uniform load for live load is 4.5. This is less than 4.8 kilopascals. So therefore, the value of F1 in the load combinations will be 0.5. So we use 0.5 for F1 in the load combinations. Next is W live load is 4.5 times spacing 2.5, 11.25 kilonewton meter. W earthquake load is 3.2 times 2.5, it's 8 kilonewton per meter. W wind load 2.4 times 2.5, it's 6 kilonewton per meter. And the roof live load 1.5 times 2.5 equals 3.75 kilonewton meter. So load combination 1 from 2010, that's the formula. This will not control because F is 0. This is due to fluids. It's 0, so 1 point for dead load only, and definitely it will not control. Load combination 2, so there are so many terms, so we have to evaluate this. Although F and thermal 0, here it's H0, lateral earth pressure, and here 0.5 of roof line load. There's no rain load, but if there is rain load, then use the higher of the roof line load or the rain load. But in this case, is rain load is 0, so LR has the only value. So 1.2 of dead load, which is 10.42, plus 1.6 of live load, 11.25, then plus 0.5 of 3.75, so 32.38 kilonewton per meter. Load combination 3, that's the formula. So again, 0.5 of 11.25 is 5 point something, while 0.8 of wind load 6 is 4.8, so that this is greater. So this controls in this load combination. So WU is 1.2 of 10.42 plus 1.6 of 3.75 plus 0.5 of 11.25, 24.13 kilonewton per meter. Load combination 4, that's the formula. So W4 is 1.2 of 10.42 plus 1.6 of 6 plus 0.5 of 11.25 plus 0.5 of 3.75. It's 29.604, but still it's less than 32.28. Load combination for 1.2 of 10.42 plus 1.0 of 8 plus 0.5 of 11.25, that's 26.13 kilonewton per meter. It will not control. For load combination 6 and load combination 7 will not control. So I do not post it here. You just look at the load combination 6 and 7. It will not control definitely. So the maximum moment or the critical factor moment using load combination using NECP 2010 load combination is equal to 404.75 kilonewton meter. Now let's proceed to 2015 NECP. So again, this will not control, it's the same. Load combination 2 is the same, so therefore we'll get the same result, which is 32.38. Load combination 3 is this almost the same, but except this one is 0.5, but this still controls. So I think W3 for 2015 NCP is the same as 2010, which is equal to 24.13 kilonewton per meter. Load combination 4, this will be lesser than 29.605, I think, because the factor here is 1.0, while in 2010 1.6. But let's compute. So 1.2 of 10.42 plus 1.0 of 6 plus 0.5 of 11.25 plus 0.5 of 3.75, that's only 26.004. Load combination 5, 1.2 of 10.42 plus 1.0 of 8 plus 0.5 of 11.25, 26.13 kilonewton per meter. So load combination 6 will not control. Load combination 7 will not control. So since the highest uniform load, factor load is 32.38, the same as that of 2010. So therefore, the ultimate or the critical factor moment is the same 404.75 kilonewton. That's it.